Welcome to this video on GPON. My name is Peter O'Reilly and I work at the CPOC lab in London. Before I start the presentation, I'd like to just go over some technology aspects. Why bother with GPON? Why bother with gigabit passive optical networking? Well, consider that single yellow cable on the screen. That's a optical fibre single mode. On that one fibre you can have up to 32 customers. Next generation it will be 64 customers. Each customer can have high definition television, high speed internet, telephone services, and more interestingly you can have transmission both ways, transmit and receive on the single fibre. It's got some very appealing aspects in that it's passive. So the building on the right there, you'd run this one fibre into the building and it will go through an optical splitter to split out to 32 different subscribers. It is possible to have a second fibre and probably makes sense, so you have a backup, so if one fibre fails the other fibre can take over. The advantage of being passive is there's no comms room where, say in that building in the basement for example, you might need some power and air conditioning to put a powered Ethernet device to deliver Ethernet services to the building. With it being passive, none of this is required. In fact, the only power consumption is when the customer plugs in their set-top box, well, not set-top box but the equivalent, and plugs it into the mains and attaches the fibre optic. So what we have here is a diagram, and in the center the cloud is I call it the GPON cloud, and that's the focus of this demonstration. To support this we have the Metro Ethernet 4620, which you'll see in the lab shortly, and there are some terms to get familiar with. OLT, this means optical line termination, and this is a optical line terminal which will be in the central office or telephone exchange. And then over on the customer premises you'd have an ONT, an optical network terminal, and that's where the customer would plug into the wall socket, and that's where power will be consumed, and the fibre will be connected into that device. That device would typically have Wi-Fi, Ethernet, and in some cases RF. Note, it is a single physical optical cable that goes from the OLT down to the splitter, and the splitter shown there is a 1 to 32 way splitter. Going back into the network, we have an MPLS core based on ASO 9000s, and I have a VPLS service providing high definition TV for multicast. The OLT or ME4620 is using multi-chassis lag across two ASR 9Ks, so there is a redundancy built into that. Downstream there's 2.5 gigabits aggregate, and upstream there's 1.24 gigabits. Different light wavelengths are used so that transmission in both directions is not affected. This kind of tube at the top there represents one single fibre, and it's just to illustrate the point that from the head end the optical transmitter on the left there is pumping out 1490 nanometers of light wave down to the subscriber, and likewise the reverse direction, the uplink direction from the customer premises, is using 1310 nanometers to to return up on the same physical medium. On top of this, there is a TDM transport where each subscriber's box is given a time slot, so that the transmission is, if you will, assigned to each subscriber in a kind of a round robin effect, so that the optical transmitter uplinking 1310 nanometers is time division multiplexed based on each subscriber having a slot to transmit back up into the CPE, into the 9000, or the ME4600 I should say. On the bottom left there is a physical port. It's an SFP, GPON SFP, and notice there's one laser aperture there, and so that single fibre would go out to the 32 splitter, 1 to 32 splitter, and then on the bottom right you can see the back open of the ONT or the CPE box, and the single mode fibre connecting into the ONT box. This is a photograph of the physical aspects. You've got the ME4600 GPON SFPs, and there's two in this case because typically you would have an active and a backup. In this terminology, the working SFP is the active and the protection is the backup. And this goes down to the 32-way optical splitter. This is passive, and you can see on the bottom left in 1 and in 2, and that allows the working and protection fibers to connect into that. And then it gets split out to subscriber 1 all the way to subscriber 32. In the lab, this is the actual equipment, the ME4620. Notice I've got GPON working on the top left and GPON protection on the top right. These are the GPON line cards, and each of those fibers go down to the passive optical splitter in the bottom left, the 1 to 32 way splitter. In the middle I've got 10 gigabit uplinks which go up to the ASR 9K chassis, providing us connectivity to the internet and the HD TV. This is an illustration of rack mounted 1 to 32 splitters. There's 6 of them, and I've just, as a remark here, put you can have 192 customers with 6 optical cables. Realistically though, you would have 12 because you'd want the backup as well. The demo itself, network, is illustrated here, and in the center they've got the ME4620 GPON with the GPON active and standby or working and protection going to the splitter, and then from the splitter out to the customer's devices. I've got a Spirent test center packet generator connected from the subscriber end going and also to the ASR 9K, and with that I can generate traffic. There's also a UCS running a VM with the Windows 7 VM running VLC spooling out high definition TV. This is all connected around those 3 ASR 9Ks with a VPLS service. This is the ME4600 actually in the lab. With my laser pen I can point a few things out. These are the switch fabric cards, and also the way we connect our web browser so we can communicate with the device. There's obviously a standby active there, and this is the GPON line card, and this is the active, and over on the right side there is the protection, so the working and protection I should say, and they go down to the transceiver. In the middle I've got just regular Ethernet, gigabit Ethernet line cards, and there are the 10 gigabit uplinks to this ASR9Ks. Up at the top there are some fans and DC connections at the back, and there's like a plenum up there which allows the air to escape out the top. Okay, let's use Internet Explorer to view the user interface for the ME4600. Only use Internet Explorer, otherwise you get odd results. I'm using Internet Explorer 9 in this case. Before you start, go into Internet Explorer, go to Tools and Compatibility Settings, and add the management IP address of the ME4600 into that, and this will guarantee you'll have a nice screen with bits not missing, which would otherwise happen. Now I'm going to point the browser at the management address, and here's the welcome screen or splash screen for the user interface. Oops, pressed the wrong button, back up. Okay, at the top we have the box is operational, and we have circuit card slots 1 to 21, and those colours go green, amber and red, showing you the status of the card. Okay, without further ado, let's log in. And once you've logged in, on the left hand side you'll see status, configuration and logs. So it's fairly self-explanatory. Status of the system, I can see the slots which correspond to the top of the screen there. Tells me what kind of cards in there, the state, temperature, CPU, memory and storage and so on. Local interfaces and modules, you can drill down into these individual cards from that selection. For example, on the passive optical network card, GPON card, I've got one SFP connected in. There's a drop down there for synchronization, PTP synchronization can be used there. And what else can we show here? There's an interface going back to the ASR9Ks, the link aggregation using 10 and 11 to 10 gigabit cards that go off, which should be shown on there, but they're not. Anyway, you can see it, get the idea. Services really are there to create VLANs, and this is what gets pushed out to the, or configures the customer's premises equipment. Here I can see at the moment on one remote equipment I've got via that splitter to the CPE, there are 4 ports, and this is actually on the customer's subscriber's box, and you can see one green is up there. I've got the dBm power of the box, and its distance and its temperature, and so it's just environmentals from the subscriber point of view. And here I can see protection schemes. This is for the switch fabric. I can see GPON type B protection scheme, which refers to working and protection going out to the the splitter uses. So that's all kind of show commands. The configuration is done from this drop down. Subscriber services. Let's take a look at the network a moment. Basically, this is a layer 2 network, and we can see from the subscriber where the CPE is that basically its VLAN's been moved across here or switched across here. On the tester point of view, I have two tester ports. One's connected to the ASO 9000, which is down here, and that's using VLAN 300, and the other side on that 172 network, and on the other side, okay, well that, so 300 has been switched across the VPLS network, or service rather, into across the MC lag into the ME 4600. Once that VLAN comes into the ME 4620, it's switched out to the customer, to the subscriber. So there is a service that needs to be set up on the CPE side. You go into configuration, pick up the remote equipment, and then look at detail there. So this is looking at that particular customer CPE, and I can see it's running off slot 2, 16 port GPON, port PON number 1, and then down at the bottom of the screen there is the service assigned to the subscriber, and really that defines the V. Here I've got two services, one's demo and one's multicast, and there's the customer tag and the the N and I tag and the U and I tag, 100 and 500. And this refers to the switching. This is an impressive demonstration, and as it says there, it's recorded as it happened. We're going to simulate a failure of the protection, or as you know, there's a working and a protection fibre optic. And at the moment, on the GUI there, we can see that we are working, or active. What I'm going to do in a moment is manually switch it over to protection, and then after a few moments put it back to working again, and we'll be able to see the video footage as this happens. So I'm going down to protection schemes, and I can see now that I've got working slot 2 and P for protection is slot 19. I've also got tester running 1000 packets a second, and I'm going to switch this over, and you'll see forcing it to protection, and then check out the drop frame count. At 1000 frames a second, one drop frame is 1 millisecond of lost traffic. Do a save, which actually kicks it off. Sometimes you have to do this clear and then go for it again. So we're going to go to protection now. Okay, so, and then say save. Gone to protection, and then down there we've got about 361 milliseconds of traffic. The 493 is multicast traffic, it's smaller. So now we're working on the protection part there. So what I could do now is zero the counters, and then get ready to move back from protection back to working. So command, I'll just do a clear because that seems to help, and then back to working, force to working. So at the moment it's saying protection, so on this bottom one I'm going to move to the working. Press save. Now we're back to working, and again we lost about 300 milliseconds when we did that. Okay, that's all well and good. Let's see it repeated though with HDTV running, and sit back and enjoy this next part. The screen will tell you when we're about to go from working to active.
Release the helmet tie-down strap. Sometimes you have to turn up really high. The smaller you are. I'm going home now.
Well, that's the end of this video. Hope you enjoyed it. Just so as you know, Felix did make it down to the ground safe and sound. You might want to subscribe to our CPOC YouTube channel. If you do a Google or a Yahoo search for Cisco CPOC YouTube, and ping that out and subscribe, or you can copy the URL below if you're feeling brave. Right, well, this is Peter O'Reilly from CPOC signing off, and I hope you enjoyed this, and look out for many more videos. Thank you.